so let's take a look at the first question here. So suppose you're walking along and you see a penny in a pile of snow and you pick it up with your hands and you warm it up to your body temperature just by squeezing it. Eventually it will get warm. When you first pick it up, it's probably going to be pretty cold, and it's going to be at -5 degrees C or so. So the question is here, how much heat is required? So we had our equation. Q is equal to mc delta T. And we need a term here. I do believe the question said it was 3.2 grams. Let's use that as the number here. All right. So this particular equation here, we have to calculate a few things. So I recommend you just go ahead and calculate delta T ahead of time, or you could plug it into the equation. So delta T. So is my final -5 or is it 37? So it's going from and to, it's going to 37. So TF minus TI is equal to 37.0 degrees C minus 5 degrees C. But careful of signs, it's minus a -5 degrees C. So we're effectively going to add it to get the overall change between the two. So definitely be careful of your signs. If one of the temperatures is negative, you're going to run across double negatives like that, which end up being positive, right? So sig figs here, I believe there are only going to be 2. If we're saying that it has 1 sig fig, no decimal places, this one has 1 decimal place, our final answer should have no decimal places. So the difference here is 42 degrees C. All right, we now just plug into the problem here. But based off the information here, do I need to go to a table for anything? Well, I was saying that here the mass of copper was 3.2. We need the specific heat, yes. So here on this table, copper is listed as being 0.385 joules per gram degree C. So I do believe we have enough variables now to solve. So Q times the mass, which was 3.2. Our C value is 0.385. 0.385. And keep your units on there so we can make sure that things cancel properly. All right, and then our temperature change, which was 42 degrees C. All right, and then now we just go ahead and break out the calculator. Always set it up first before you take out the calculator. You don't want to waste your time doing calculations that are incorrect. Just make sure it's set up correctly before you start punching numbers in. 51.744. How many sig figs should my answer have? 2, yes. So 52. And now you may have a question on what are the units. We are working in a heat problem here. Chances are the units are going to be joules or calorie. So we can check this. Our grams cancels. And our degree C cancels. We have joules left behind. So that is our unit, 52 joules. It's not very much heat at all, honestly. All right, I want to go ahead and add one more little step to this, just so you can see a conversion. And the question here is, how many calories is that? So I'm just going to stack it on here. I want to figure out how many calories there are from joules. So this is defined to be exactly the heat capacity of water. So it's 4.184 joules per 1 calorie. All right, and without clearing my calculator from the previous example, I'm just going to go ahead and divide it by 4.184. And I'm getting 12.367, etc. So 2 sig figs. I'm going to write my answer as 12, and be careful here, lowercase c for a calorie. basically what the next set of problems are, I try to encompass every possible variety of questions you're going to have here. So if you think about it, if you have these, 1, 2, 3, 4, 5 variables, basically all the different variations of which variable are they asking for. So you have to take a look at the wording to figure out which one it's asking for. All right, so the next question here. This one is saying that you have 89 joules of heat applied to a 12-gram gold coin. What is the temperature change? So what I like to do is just go ahead and start off with the equation. So we're pretty sure it's going to be asking for the use of this equation. And which variable should I solve for? Probably delta T. So I'm not going to show the algebra here, but it's just divide both sides by MC. So you end up with Q over MC. All right, now we just plug in our values. So Q is given to us. Also, I want to point out that if, while you're working these out, it might be useful to label the variables in the problem itself. So I'm going to go ahead and do that. So this value here is our Q. This value here is our mass. And the question is asking us, what is delta T? So that may be an easy way to just label things to figure out what the question is asking you. All right, so, and you're going to notice when you do these problems out of your homework, they're oftentimes not going to list the heat capacity in there because they're going to expect you to go to that table. Unless it's not in the table, then they will give the problem or the heat capacity to you. All right, so divided by 12 grams, I have gold on this table here to be 0.128. So 0.128. And the units here are joules per gram degree C. All right. I do believe we have everything that we need. I want to go ahead and check that my units are correct because we have a little bit of weirdness happening in here. All right, joules are going to cancel. Grams are going to cancel. And then we have degree C there. But look how it is. So if you look at everything here, we have 1 over degree C. So that is effectively an inverse of an inverse. So in that situation, we have just degree C there. So that's how the units are working out. All right, now that I checked my units, I got everything set up, I can now pull out the calculator to use. Did you notice how I punched that in? I did divide and then divide twice. Depending on how you punch them into your calculator, if you write it as 89 divided by 12 times 0.128, you may not be following the order of operations properly. So I do it one number at a time, making sure I use the divide or multiply depending on which part it's on. So I did divide twice here just to make sure that things were punched in correctly. All right, so how many significant figures should I have? 2. So things such as the 89 or the 12, those would be measured. The 0.128 came from a table. That's an exact number. So final answer, 2 sig figs should be 58 degrees C. We have 56 joules of heat is applied to 11 grams of some liquid. We don't know what the liquid is. And the temperature raised from 10.4 to 12.7. What is the heat capacity? Start off with your equation. Q is equal to MC delta T. And I'm going to go ahead and label some variables here just to make sure we're doing things correctly. So the 56 here is our Q. The 11 here is our M. And then which one of these is TI? Is it the 10.4 or the 12.7? That's your final. So it's whatever you're heating from, that's your TI. What you're heating to is your TF. So this was our starting condition. It says from this quantity. So this is our TI. This is our TF. The reason why we do it that way is because if you're heating something up, the change in temperature will be positive. If you're cooling something off, the temperature change will be negative. So it basically gives us a directionality to it. All right, so we almost have enough here. I would go ahead and calculate delta T first because we're going to need that here. So we have 12.7 degrees C minus the 10.4. Recall that delta T is TF minus TI. Oops, 2.3 for that. And I want to go ahead and keep track of my sig figs here. I should have 1 decimal place, so 2 sig figs at this point. And units are degrees C. You could just go ahead and write 2 SF there just to keep track. All right, now that we have everything that we need, I'm going to go ahead and solve for the correct variable. Which variable should we be solving for? C, because that's what the question is asking for, right? What is C? So here we have C is equal to, all right, I need to bring these terms down. So I end up with Q over M delta T. All right, and you can always check if your algebra worked out properly if you plug in your units and things cancel properly. All right, so the heat term on top, the mass term here on the bottom, and then we have our temperature change, which was 2.3 degrees C. And we want our units to be joules per gram degree C. I think we're good. Nothing's going to cancel here, so it's all going to be in the final answer. And I get 2.21, etc. 2 significant figures. So my final answer here is 2.2 joules per gram per degree C. So we have 45 grams of water, kilograms of water. It's absorbing this many kilojoules of heat. And we're being told what is the initial temperature, and the question is asking us what is the final temperature. So the algebra here is a little bit different. So I want to go ahead and label some variables here. So this is M. This value here is Q. This value here is, notice it's even in the wording here, initial temperature. That is TI. The question is asking us what is TF. And we know what the heat capacity of water is. It is 4.184 joules per gram degree C. There are 2 issues that we have going on here. One is we have the algebra we have to do. We also have to be careful of our units. So notice here these are kilograms and kilojoules. So we're going to have to take that into account. So instead of adding a step there, I will use the prefix multiplier for what they're for, and that actually makes the problem a little bit simpler to work out on your calculator. But first things first, I want to do some algebra. So we know that Q is equal to MC delta T. We also know that delta T is equal to TF minus TI. So I'm going to go ahead and plug in this term for delta T to get a final equation here. So Q is MC, parentheses, TF minus TI. And I need to solve for this one. So in order to actually break this apart, I can't just add this now, can I, to both sides? I have to actually bring this part over first. So I'm actually going to do this one stepwise for you. So TF minus TI is equal to, so I'm bringing this down, and then one more step. So we're just going to add the TI to both sides. The one thing I'm going to point out to you guys that may make this easier to keep straight in your head is that this term right there, that is delta T. So if you think about it in terms of this equation, or the simpler form, this is basically what you're doing here. So Q, it says 345 kilojoules. So kilo was how many? 1,000. So instead of K, what I'm going to do is put 10 to the 3 there instead. That is in place of the K prefix. I do want to point out that is not proper scientific notation, but it basically just saves us a step in conversions. You're going to see that this is going to be useful again in the next step here. Notice here that the mass term is also in kilograms. So we have 45 times 10 to the 3 gram. Those terms are going to cancel. So we don't even have to bother about a conversion here because they both canceled. That's not always the case. This one just happened to work out that way. All right, the last thing here is we need a specific heat of water, which I wrote again up here. Commit that number to memory. It'll be useful. All of that is our temperature change. So we can go ahead and now add our initial temperature, which was given to us as 22.1 degrees C. All right. You got to be careful of our sig figs here, so let's go ahead and take a look. Just keeping proper sig figs here. How many sig figs should this number have? Should be 2. So if we were to stop here, we would have 1.8 degrees C. But I don't want to round yet, so we're just going to go ahead and add the last number, plus 22.1. All right, our final temperature should be 23.9. We get 1 decimal place here. All right, and that is degree C. And then try to identify all the variables in here. We have Q. Our C is labeled here. It's an ETOH. That's actually a shorthand for ethanol. And here it says ethanol initially 11 degrees C. That is our TI. All right, based off of what the question is asking us, do I quite have everything I need here? I don't have M, do I? But I have enough information to get M. So the problem is giving us density, and we're given the volume. So you could just treat it as 2 problems, or you could just plug everything into one. I'm just going to go ahead and treat it as 2 problems here. So the first thing I'm going to do is solve for M. And what should I have? Should it be D times V or D divided by V? Should be D times V. Get in the habit of writing in your units, because that way you can see if you messed up your algebra, your units won't cancel properly if you messed up on the algebra. All right, so this is grams per milliliter. And then our volume was given to us, thankfully, in milliliter. All right, and then we multiply these out. The mLs will cancel, and we will be left with grams, which is the proper unit for the heat capacity equation rather. At this point, I should have 2 significant figures because of the volume term only having 2, and then the 0.789, the density would be a table value. All right. Here, we have to recognize that delta T is equal to TF minus TI. It is always final minus initial. So then we can go ahead and take the equation in this form with the delta T written out as TF minus TI. I then need to do some algebra to solve for TF. So first things first, if you go ahead and divide both sides by MC, you get Q over MC. Now we can bring over the TI. So we end up with Q over MC plus the initial temperature. Recall that the Q over MC, that is your delta T term. So you could think about the algebra that's happening here in terms of what's happening up here. And then our heat capacity was given to us. This is not water, so we have to use the correct heat capacity. And then we have plus the initial, which was given to us as 11 degrees C. All right. Another thing to point out is that oftentimes in these problems that you're going to run across, delta T is often a small value. It all depends on how much heat is being put into the system. At this point, I should have 2 sig figs, right? And I get 20.198, which is going to round to 20. 2 sig figs, no decimal place. So to keep that from being ambiguous, go ahead and put a decimal there or scientific notation, whichever works for you.